Hi, welcome to the Best Robotics Simulink tutorial. I'm George Pandya. I'm the best alum from 2012, 2013, and happy to walk you through Simulink, which was super valuable for our team. So this is a part of a larger, the kickoff presentation, several breakout sessions, all of which you can find under the files shared with your team and the Best National Registry, including this breakout session and several others, and links to all the other Q&A meetings. So in this tutorial, I'm just going to walk you through kind of the basics of Simulink, what it is, what the programming environment is, tell you a little bit about Mathworks and Simulink, and then go through a couple of programming examples. So what is Mathworks? They're a national partner of Vex Robotics. They're sponsoring, the competition, and they're the creators of MATLAB and Simulink. They just want to encourage more use of their software. It's an industry standard used all over, the country by engineers in all sorts of different industries. So it's always great to get familiarity with it. So just a little bit more about Mathworks. What this is talking about specifically is Simulink, which exists within MATLAB, which is a Mathworks design programming environment. Think of it more like Python, more for data science, modeling, engineering calculations, things like that. And some of the advantages for you to use it in your best team, obviously there is, first of all, awards. There's a Simulink award, which is optional, but obviously it would be great to participate. And just overall, the benefit of it is getting that knowledge, so that when you go to engineering school, when you work in industry, you'll have a knowledge base in Simulink, and you'll be ready to go and use it in all sorts of more advanced projects in the future. There's two ways to access Simulink tools. You can either download it to your PC. You'll need a Windows computer. The Mac version of MATLAB doesn't really work super well. And I believe the licensing might only work for Windows. Not entirely sure on that. But there are team licenses. Talk to your team mentor about that. So let's talk a little bit more about Simulink. So Simulink is a graphical programming environment. It feeds into MATLAB, which is a more traditional text-based programming language. What Simulink does is that it uses a bunch of drag and drop blocks, and it lets you connect the blocks in different ways, so that you can create mathematical simulations that way. So each block represents a different sort of mathematical function. There's like addition blocks, there's multiplication blocks, there's calculus blocks, things like that. So that any sort of physical process you're trying to model, you can model in Simulink. Like in engineering college, I did a Simulink model for a hot air balloon that modeled, how it transferred heat from the inside of the balloon to the outside, what sorts of forces that created to lift it up, and how that force changed over time. And then that automatically was able to calculate then, the trajectory over time, the speed, the acceleration, the height, all that. So it's really convenient because you can kind of lay out the equation you're dealing with graphically, step by step, which is good for you to understand as the engineer and kind of really break down the problem, and also makes it easy to model without any super complicated code. It's also got a lot of plotting, debugging, analysis tools to further aid your design studies if you want to make sensitivity graphs, things like that. Very useful software. So first of all, let's talk about installation. You get a free 1-year license through Vex Robotics. It's just online, available for PC and Mac. And there's a separate, I believe there's when you download it, there's an option to install the Simulink plugin. If not, you can also download Simulink separately. And then as far as getting the licenses, make sure you just talk to your team mentor, your faculty advisor. They'll have to create a Mathworks account to register the licenses. And then from there, you'll get your license keys via email, and then you can just download for installation from your own account. And the way you do that, you just go to My Account, you add the license key that your team mentor gave you, and then from there, you'll just be eligible to press that download button. Run the installer, and it's a huge download. It's like gigabytes and gigabytes, so keep that in mind. But that's pretty much all you need to do. There's one more thing. Since you are, most likely going to be using this for your robot control systems, you need to install the Vex Cortex Support package. This is just a plugin for Simulink, so just follow that link there, and that should be all you need. This presentation will be will be in the file as well. Finally, there's help and tutorials. If you, inside the Simulink environment, if you go to help, you can access all the documentation for using the Vex controller package. We'll also go through a little example on that too. So just for a simple Simulink programming example, just run MATLAB, open up a new Simulink model, there's several ways you can do this. You can either, in MATLAB, you can click on New and then Simulink Model. And then another way you can do it is that in MATLAB, in the command window, you can just type in Simulink and it'll automatically launch it. This has to be the command window, not the programming environment. And finally, there's a Simulink button under Home when it's installed, and you can just click on that. Any of those work. This bottom picture is what Simulink would look like. It says Simulink academic use, and there's a little button with the 4 windows. That's the library browser where you actually create your blocks from. I will talk through that shortly. But first of all, when you open up Simulink, it'll give you a lot of templates to choose from. You can either do a blank model or blank library. You can create a code generator, signal processing, all sorts of things. I recommend just playing around with that for what your team might need. Most likely a blank model is a good starting point, unless you really need, there's a specific setup you're already going for. You can also create templates yourself. In Simulink, you just hit save, file, save as template, just like anywhere else. So let me just talk, I threw a lot of terms at you, block, Simulink, Explorer, whatever. So let's just, take a step back and talk about the terminology. First of all, the Vex Cortex thing, I call it a plugin, support package, same sort of thing. It's just all of the all of the files that you download to make Simulink work with the Vex Cortex. Includes the library, compiler, download, utility tools, all that. Then Vex has a companion app on the side, which is like their graphical interface that that lets you actually use the software. Now the Simulink model is whatever you create when you launch Simulink and you save that the model, whatever robot program you're creating, anything else, that's essentially the Simulink save file that includes all of the blocks. Inside that Simulink model, the blocks are specific mathematical functions that all fit together. You connect them with arrow keys, so it's like sequential, right? It goes through multiplication, then addition, then whatever else. And then you can create a library, which is a group of blocks. So you can save, like, if you have one function for, I don't know, let's say like an arm control, right, on your robot, and you want to apply that in multiple places, you can save that as a library and just import it in the library browser. You can also generate C code from the Simulink model if you want to do, other sorts of testing with it and other applications. And finally, you can run the Simulink model. So you can, whatever you create, you can actually make it run a simulation and collect the data that comes from it. So to start, click on the library browser, which is, once again, it's grayed out, but it's that picture, the four windows there, and that opens up these libraries. So there's so many different types of blocks all over. I just recommend browsing through it. It's pretty impressive. A lot of the blocks involve a lot of functions that are kind of aggregated together. But there's also simple stuff, like I was saying, addition, multiplication. You can find those under math operations. There's a scope block, which I'll talk through in a sec, that lets you see kind of the output of your result on a graph. There's gain blocks, which just apply like a very simple, plus minus, sorts of multiplication, things like that. So the basics of a Simulink block, there's an input and an output. So you take a source, you always start with a source block. The source block can be fed from multiple places. There's random number generator blocks. There's you can have them, like in this case, that's just a constant. And then these arrows are referred to as signals. So the way this works is that the source block, the value of it goes to the signal to the function block. This is a squared block. There's all sorts of other ones. And that, that applies whatever function of that, sort of square the one, and then that signal, the new signal will go to the sync block, and then it'll give you the output. So pretty simple, just drag and drop. You can see here the absolute value, adding algebra blocks. You really can do any sort of math with Simulink, which is what makes it so powerful. Let's do a simple programming example. So just want to implement the simple equation where a equals c times the square root of the quantity x squared plus y squared. So you want a to be the output, right? X and Y are the input blocks, those first signal blocks, and then C is just a constant. So I actually don't currently have Simulink installed on my machine, so I'm going to talk you through it in PowerPoint from when I did this before, but you should be able to get through it pretty easily. So first of all, you want to create these input blocks. So you want to go to the block browser, you want to find those constant blocks, and then X, Y, you can name them by just double clicking on the block, and then give them their values as well. So pass the input on to these math functions and square them, right? Because we want to take X and Y, always look at this in terms of the order of operations. How you do it, just like normal math. So you square them, right? And then you take an add block, you add them together. That signal goes to the square root block. And then you take a product block and you have this 3 that's a constant and it just multiplies with the product block. You find that sync block and that gives you your answer. So really simple example, but it just kind of shows kind of the general way of putting this together. You can do it with any sort of advanced equation. So secondly, let's have a look at the VAX programming. There's a few links here. There's a default program that we'll look through for Simulink, in the slides shortly, and then there's a bunch of getting started videos. This is probably going to be a lot more useful for you guys than just a simple x squared plus y squared, because this actually lets you do motor your robot control systems and actually simulate them. So let's have a look into that. So when you open the best default Simulink program, and once you download it, it'll just open as a Simulink file. It has all these weird like new sorts of blocks. That's what you downloaded from the Vex plugin. And once you have that plugin downloaded, all of those these Vex blocks you can find under that library browser. So let's say we want to make a few changes to this. This is just kind of like a control system. You have these controls feeding into the motors from various input sources. So let's say these are a couple normal things that you would probably do as you're testing your robot and coming up with your control schemes. So first of all, you want to change port 6's motor control from your joystick, channel 4 to channel 3 and reverse its direction. And the second one is, let's say you want to remove your joystick's analog control of the servo, and you want to use digital channel 5 and up. So you want it to be input of 127 when pressed and 64 otherwise. These are just small tweaks that you'll keep making to make it easier for your drivers. So to change port 6, you have this here, and I'd recommend your programming team kind of follow through with this along on your own machines. But you want to click on the joystick block, and it's easy. Just the analog channel. You just select that, hit OK, and then for the second thing, just it's out of order, but like I said, you can find this all under the library browser. That motor support package, and you can find all those motors, and that's how you get these blocks. And then for inverting the direction, like I mentioned, there's a gain block. So you just add that gain block, and you change the value of the gain to -1. So that just flips the polarity, of the direction. So now, up is down is up, or vice versa. So that's easy. For removing the joystick analog controls of the servo, all you have to do is delete those blocks that control the servo. So all of this stuff related to the joystick input, just get rid of that. No more joystick control of the servo. If you want to use digital channel 5 and up, you just add a switch. That way it's like 0 and 1 under certain conditions. And then you add a gamepad button to make that channel 5 and up. And that's really all you can do. And then you add the output range so that it's either, depending on the value of the switch, -164 or 127. And that feeds into the servo just like that. And like all these ranges and everything, I'm talking through them kind of quickly, but these are just stuff that you'll really get immersed in as you start to create your control scheme. So I wouldn't focus on that, more kind of on the workflow of how to create these blocks in Simulink. Finally, when you've created your model, if you want to compile and download them, you can click on this button here, and that downloads, that can compile it into C. You can download it to put on your motor controller, whatever you need to do. So pretty easy to use, very graphical. I've gotten questions before that it's like, if you're more comfortable with a text-based programming, can you do that on Simulink? The answer is no. Simulink is pretty strictly graphical. It has benefits and downsides. You can always do this separately in RobotC or MATLAB or whatever else you want to do, but Simulink offers a pretty easy way to do this stuff graphically. There's also more advanced features. You can create subsystems of Simulink code that kind of feed into each other. You can create state flow, which are kind of decision processes, sequential logic. And there's also an external mode, which is this new thing since a couple of years ago, that can be run externally. Finally, I'll talk through another thing, like the example we went through with the VAX programming was specifically about actually creating those control schemes and uploading that onto your controller. And your robot can actually respond to controllers on your joystick. But let's say you want to be earlier in the design process and just do design analyses on what works, how much torque you generate, for example, here from different sorts of arm movements. So you can do that. You can have the math, you can have the arm angle, the arm length, all that, and just feeds in. And if you vary the input on the on the arm mass and the angle, so it looks like mass and length is constant here. You're just varying the angle, and then as you can see that as the angle increases, torque decreases, which as you'd expect. So that plot you get from scope, which is taking the input of the torque. So this is how you create those design studies. You can find the sensitivity charts. Like the torque drop is smallest in this first part from 0 to 10 degrees of angle. So maybe you want to design your robot around that. That's kind of the engineering design process that is followed in industry, and that's why this is so powerful. Finally, just showing a little bit more about the Vex Support Companion app. If you go under Apps in MATLAB, you can click on that. And there's a lot of demos, FAQs, example models that you can go through to make this a little bit easier. Finally, I mentioned earlier there's a Simulink Design Award. One team per region is recognized for having the best robot program designed in Simulink. Just to submit, all you need is a Simulink file and like a short, couple minute long video that's technical, explains what you did, but make it fun. And it's a $1,000 cash prize, sponsored by Mathworks. So definitely worth doing, especially if you should be using Simulink, honestly, to design, a good robot. So you'll pretty much have most of what you need to submit this anyway. Just talking through some additional resources. There's there were a lot of links in the slides that I'd recommend you go through and click on, for the VAX support, MATLAB downloading, all of that. If you need any more training, getting started videos, all of these links are great resources. There's also a few seminars, webinars hosted by Mathworks to talk through Simulink in a little bit more detail than I covered here over the next few weeks. So, you can sign up in this link here. Your school also, in addition to the free licenses for 1 year given by Mathworks for best teams, your school can get a license for the whole school. So for any teachers out there, this is also an option if you want access for the broader school beyond the best robotics team. And with that, thanks for taking the time to listen to the Simulink presentation. Hope it was helpful.